Dear students, good morning. Namaste. This is the vector sixth part. In the fifth part, we completed exercise 10.1. Okay, now it is based on the fundamental concepts. Okay, now right. Now we are going to discuss about some more concepts. That is a free vector, position vector, and a free vector can be expressed in terms of a precision vector. These are the three concepts, not types of vectors. Types of vectors are already over, and on that one we complete one exercise also. Now we are going to discuss about these things. Okay, now here a free vector. What is a free vector? Observe me. Already I told you. Already we discussed it. Vector means it is a three-dimensional geometry and algebra. Vector, a concept. It is not on the two-dimensional. Vector, a length and a direction. So here is a particle is moving from one place to another place. Means it is a purely three-dimensional geometry. Our room is, you assume your room, where you are observing this video, that room is a space. Horizon, x-axis, this one you assume, this one is x-axis and it is y-axis, and you assume it is z-axis. This is a room. My arm is say it is A and this tip is B. A B bar, a vector. PQ bar is another vector. CD bar, LM bar, like that. RS bar, MN bar, like that. These are the vectors. Now, very clearly we will discuss. Free vector. A free vector whose initial and terminal points are free from origin. This is important. Origin. It is free from origin. That means a V bar, this is the initial point and terminal point. Here A and B are initial and terminal point of a vector. These are not origin O. Or PQ bar. Also, P is free from origin. Q is free from origin. RS bar. LM bar. Similarly, CD bar, like that. For example, it is origin. It is x-axis and it is y-axis. You assume it is z-axis. Okay, now, like this, in this space, there may be 2 points AB. Then AB bar, it is not on the xy plane. It is in the space. Already I told you, this is x-axis and y-axis, this is z-axis. My arm is AB bar, this is A and B, AB bar. And another one, PQ bar. Let the top is LM bar, like that. These are all free from origin. Okay, now? So, a free vector means whose initial point and terminal points both are free from origin. Those vectors are called as free vectors. Okay, now? Next. You write the diagram also. These are the things. Or otherwise, I will you see, diagrammatically, it is origin, it is x-axis, y-axis, and z-axis. Here is A and B. The direction is A to B. So AB bar is a free vector. It is PQ. PQ bar is a free vector. LM. LM is a free vector. RS is a free vector. All these vectors are free from or independent of origin. That the origin is not connecting with the initial point and a terminal point of any vector. Those vectors are called as a free vectors. Okay, Nana? Yeah. Next concept. Position vector. Position vector means suppose in the space a point P is there. P is any point in the space. Then the position vector of the point P, for a particular point P, OP bar is position vector. Suppose R is there, OR bar, the position vector of R. Suppose Q is there, OQ bar is position vector of the point Q. Like that we have to say. A is there, OA bar is position vector of point A. Like that. Once again, origin, x-axis, y-axis and z-axis. There is a point, my tip, finger's tip is point, you assume, there is a point P. Then, from origin to that point is OP bar, is position vector of the point P. OB bar, OA bar, OC bar, OL bar. Okay now, O is initial point to any point in the space. Okay now, like that position vector is defined. You try to understand position vector and free vector. First is position vector, next is a free vector. Position vector means initial point is a origin. Free vector is, it is free from origin. Very simple. Okay, no? Diagram also it is. That OA, OP, OR, OQ are not lying on the XY plane. There are three planes. XY plane, a wall is there. YZ plane, this wall is there. XZ plane is a floor. Like that we assume. But A, P, Q, R are lying in the space itself. Okay, no? Like that we have to take it down. Got it. Now, third one. This is a note. Any free vector, observe here. You observe here. Any free vector can be expressed as the difference of position vectors of terminal and initial points of a given vector. You see, clearly I will tell it. This is about the note. Suppose AB is a free vector. Any free vector. AB is a free vector, just you assume. That means it is in the space, you assume, like this. It is in the space. It is x-axis, horizon, y-axis, and it is z-axis, okay. Then, what is there? We have a position vector of point A. OB bar, position vector of point B. If it is given or not given, it is understood. If a point is there, certainly there is a position vector for that particular point. First we take AB vector only. AB vector only. Then A and B are initial and terminal points. Automatically, it is not given in the question, but it must be there. It is there only. OA bar position vector of the point A, OB bar is the position vector of point B. Okay, now you see, in triangle OAB triangle is there. OA bar plus AB bar is equal to OB bar. Will you agree? By triangle of vectors, addition of vectors, O to A to B is OB bar. OB bar is a displacement of or addition of OA bar plus AB bar. We know it well. Now what is AB bar? AB bar is OB bar minus OA bar. You agree? AB bar is, I am sending OA bar to that side. OB bar minus OA bar. Now you see, OB bar is AB bar is nothing but OB bar minus OA bar. That means a free vector. AB bar is a free vector. A free vector AB bar can be expressed as the difference of minus is there. The difference of position vectors of B point and A point. OB bar minus OA bar. Difference of position vectors of terminal point, first terminal point and then initial point of that particular AB bar. Suppose what is PQ bar? It is OQ bar minus OP bar. You agree? PQ is a given free vector. It can be expressed as the difference of position vectors of terminal and initial. Suppose LM bar, it is OM first terminal point minus ON. Suppose CD bar, it is OD bar minus OC bar. Okay, like that. First one is, first you learn it that one. Position vector. Position vector means for any point in the space, three-dimensional space, it is connected with the origin as a initial point. OP bar, OB bar, OA bar, OQ bar, like that. But free vector, nowhere it is connected with the origin. It's a different one. AB bar, PQ bar, RS bar, SQ bar, LM bar, like that. And by using these two concepts, any free vector can be expressed as the difference of like this, terminal and initial. Okay, Rena? That is the important, very important concept. Okay. Okay. Now, this is an important concept. Actually, vector is geometrically, here it is expressed. Okay, now? But its name is the components of a vector. Vector means, up to now, we can define a vector, mathematically of course, length and direction. A, B bar, 10 units, 15 units, like that we define, yes, okay. But if you want to write as mathematically if you want to write the vector, to show a vector in written mathematically, so it needs something, some numbers. Okay, for that purpose, the component of vectors are formed. Here, it is a different one. Components, with the help of components, we can define a vector. This concept is very, very important. Okay, Nana? Yeah. Already, I told you, it is x-axis, y-axis and z-axis. Okay, Nana? Just I changed y-axis here and z-axis here. Okay, Nana? Our room. It is our room. It is x-axis and we assume this is y-axis and it is a z-axis. Okay. There is a point P. In this space, P is a point. P is a point. Try to understand. P is in the space. It is not lying on this wall or on this wall or on the floor. Okay, now? The floor is a plane. It is containing x-axis and y-axis. And this board is a plane containing x-axis and z-axis. And we assume here is a wall. This is based on y-axis and z-axis. Okay, like that we have to assume. Imagine. So x-axis, y-axis, z-axis. This is a plane, floor. And it is a wall, a separate wall is there. And here is a bone, or otherwise wall, you assume. Okay, na? Yeah. But the P point is here only. Here is in the space. Try to understand. Not it is on the board wall, that is a XZ wall. P is not on the YZ plane. P is not on the floor also. It is in the space. Now, through the point P, I can draw a three planes. Please try to understand. P, F, C, E. One plane, P, F, C, E. This one. P, F, C, E. It is a new plane. It is passing through the point P. Similarly, P, F, B, D. P, F, B, D is a plane. It is parallel to XZ plane. But this plane, you see, this plane is, that is PFCE, is a plane parallel to ground. Okay, na? And PFBD is a plane, it is in front of us. It is parallel to XZ plane, XZ plane. Okay, na? XZ plane is that wall. That wall, it is parallel to a PFDB. Okay, na? And PDAE. PDAE is a plane, is parallel to this wall, XZ wall. Okay, na? Like that we have to assume. It is somewhat difficult because a new concept about the three-dimensional geometry. We have to take this one, otherwise not possible to explain this components of a vector. Once again I will draw here. You see, like this. It is x-axis, y-axis, z-axis. P is a point. You may feel that P is on XZ plane, just like XO, Z plane, that wall. This is this side wall, and it is a floor. Okay, Nana? This way, XZ, XY is the floor, XZ is that wall, YZ is this wall. Okay, Nana? P is here only, in this room, in this space, P is here. Okay, Nana? You see, if you draw like this, now we get a cuboid, okay, na? Like this, cuboid. It is A, B, and it is C. And it is D, E, F. Okay, then? Through the point P, first I construct PDCF. PDCF is top, just like a lid, top. It is parallel to the ground. Again, PFBD, this side is, this is one plane. It is parallel to XOZ plane. And PDAE is a plane, this side wall is parallel to YZ plane. Okay, like that. So that we can get a cuboid. That is the main thing. Now you observe here. Let P be any point. It is any point in the space. Just like there I draw that one. A 3. Let 3 planes, the number 3 planes, already I discussed, PECF, PECF, and PDAE, it is a PDAE, that side, PDAE, and PFBD, okay, then? These 3 planes which are be drawn, those are parallel to these are parallel to xy plane. Suppose you see PECF. PECF is top is parallel to this one, this plane, total plane, xy plane. Okay, now PDAE, this one, it is parallel to YZ plane. Okay, now next PFBD, our side, it is parallel to XZ or ZX plane. Okay, now? Okay, now? Like that, we construct which can be formed a cuboid. This is a cuboid. Cuboid means it is just like a box. Okay, now? There are 6 faces. Okay, now? This is a cuboid. Where OA, this cuboid, where it cuts x-axis at A, that distance O to A horizontal to that point A is x-coordinate. OB, where the cuboid cuts y-axis, OB is y-coordinate and OC is a z-coordinate. Suppose in our room, if a box is fitted and it is placed in the corner, you assume, in the corner, just like is there, x-axis, y-axis, z-axis, a box is put in the corner that touches that corner, that x-axis at A, y-axis at B, z-axis at C, it cuts. So OA is x-coordinate because it is on x-axis, OB y-coordinate and OC z-coordinate. Okay, Nina? That is the thing. Okay, now? Try to understand. The main thing is drawing the three-dimensional, that is x, y, z, space. It is called as space. In the space, we are taking P point. Through the point P, 3 different planes, PECA, PDAE, PFBD, which are parallel to XY, YZ, ZX planes. So that it covers, it completes, it constructs, it forms a cuboid. What is cuboid? Cuboid is ADBFCE, is a cuboid. That is a form. Okay, now, where OA is x coordinate, OB is y coordinate, OC is a z coordinate. Now, okay, now? Yeah. Just, you see it. Okay, now? Again, here OA is x units. Then OA bar is x I cap. And then OB is equal to y units. Y coordinate, y units. Then OB bar is equal to y j cap. I will tell it. And OC is equal to z units length. Then OC bar is equal to z k cap. Here, observe it. Already we discussed, I taught you, is x coordinate. What is x coordinate? OA is a x coordinate. OB is a y coordinate. OC is a z coordinate. Okay. But I need OA bar. Here is a small thing. On x-axis, on a positive x-axis, I cap is a unit vector. Unit length, that direction. O to x is direction is there. I cap is a direction. 1 unit length, I cap. On y-axis, j cap is a unit vector. Similarly, on z-axis, k cap is your unit vector. Now you see, what about OA bar? OA is x units length. We know it well by the three-dimensional geometry. P is a point having x coordinate, y coordinate, z coordinate as x, y, z. OA is x units length. And it is having direction I cap. I cap means unit vector along that x-axis. Means 1 unit length direction is there. So in this x-axis, what is the direction means? I cap is direction. Of course, I cap is unit vector. Unit vector means 1 unit length and direction is there. O to x is the direction. Direction means I cap. O to y is the direction. Direction here is j cap. O to z is a direction is k cap. And I is perpendicular to j, j is perpendicular to k, k is perpendicular to j. So they are mutually perpendicular. That means x, y, z are mutually perpendicular axis. Okay now? Very simple. I cap means unit vector, of course. It is a unit vector. I cap is there. I cap a unit vector which indicates the direction O to x. So OA is of length x and lying on x-axis, having the direction I cap. X-axis means I cap. So OA bar is x I cap. X I cap. There is length x and I cap. Okay now? Lambda A bar. Previously we discussed the multiplication of a vector with a scalar. Here x is a length. It is a constant. We are multiplying the direction I cap. We are multiplying the unit vector I cap, which is our x-axis. That means x I cap means that is OA bar is lying on x-axis in the direction OX and having the length x. Yes, perfectly length is there, direction is there. So OA bar is a vector, x I cap. OB bar is a vector, similarly. YJ cap. OC bar is a ZK cap. Where I cap, Z cap, K cap are unit vectors along x, y, z axis. Yes. Okay, Nala? That is. Now the thing is OD bar. What is OD bar? You are assuming OD bar. You see, OD bar is equal to OA bar plus AD bar. Will you agree? In the triangle OAD. From the triangle OAD, O to A to D is OD bar. Displacement. That is OA bar plus OB bar. You see, observe me. In the parallelogram or in the rectangle, here it is appearing as a parallelogram, but actually this is a base for this cuboid OADB. OADB is appearing as a parallelogram, but in the box base is a rectangle. What is it? Parallelogram, rectangle. The opposite sides are equal and parallel. So AD bar is nothing but OB bar, equal vector. So here it is okay na? AD and OB are parallel sides. Okay na? Yeah. So instead of AD bar, it is equal vector OB bar. What is OA bar? X I cap. It is Y J cap. You write like this. Okay now? So that is OD bar. Now OP bar. You see, what is OP bar? OP bar is equal to OD bar plus dp bar. It is in triangle. In a triangle ODP. Okay, na? In the triangle ODP, see there. OP bar is OD bar plus a DP bar. What is OD bar? First we write once again. OD bar plus DP bar. DP bar. DP bar is nothing but say ODPC. It's a diagonally, it is a cut. It is also a rectangle. You try to understand it. ODPC is a parallelogram. It is parallel to and equal. DP is nothing but OC. Okay, na? Here also DP and OC are parallel sides. Okay, na? Now, what is OD? What is already, you know it. It is x I cap plus y j cap. But OC is already there. It is z k cap. So, any vector or p bar where p is a point whose coordinates are x comma y comma z. OP bar is xi cap, yj cap, zk cap. Okay, like that we can define any vector. That is any position vector of a point P, x comma y comma z. Now the final. Observe me. I will write here. Observe me. Hence, OP bar is equal to xi, yj, zk cap. Okay, na? Where x comma y comma z, not put it in a bracket. If you put in bracket, they are coordinates. You write as it is. X, y and z are called scalar components. They are called as scalar components. Whereas, observe this. Whereas xi cap, yj cap, and zk cap are called vector components. Okay, na? Components. Vector components, because I cap direction is a length direction. Vector. So si cap, yz cap, zk cap are called as a vector components. But it is simply scalar component because only length scalars are there. Whatever it may be, any vector, any position vector of a point P whose coordinates are given, then we can easily suppose P is a point 5, 6, 7. Then OP bar is a 5i, 6j plus 7k. Okay, na? Suppose P point is 5, 0, minus 4 is there. Then OP bar is equal to 5i minus 4k. Okay, na? 0. Y is 0. Okay, na? Suppose P point is 0, 2, 3 is there. Then OP bar is equal to 2j plus 3k. Why? Because 2 is related with j. J means y coordinate, z coordinates are there. So j cap, k cap will come. Okay, like that we can define the component of vectors. Okay, is it clear? Bye.